Okay, this is one of my older machines, one of my probably my 15th or 16th build of the generator. I kept changing the way that the generator was put together, making it better and better. And this is the final kind of a version of the generator, even though there are still some things I've changed since then. But I just wanted to show you. Here's my thumb between two of the coils. This is using the size rotors that I sent you. So you can see that my thumb barely fits between two of the coil holders on the generator. So let's go over here. And let's look at this machine. By the way, that is a 6 and 6 setup. This is a 6 and 5 setup. So you can see that my thumb has a lot more room between this, but it's not just because it's a 6 and 5 that with only 5 coils in it instead of 6. It's also because it's bigger. Okay, and it's bigger for a reason. Here is where the coils fit in, and in between each coil, dead center between each coil, is a bolt. All right, so what are those bolts doing? All right, and let's flip this around and take a look, and let's just talk about one of them. When your coil goes in right here and the core sticks through and is flush, directly across center from that, I have this. And what that is it's a piece of PVC pipe with a little 1/2-inch thick spacer in it. In the center of that 1/2-inch thick spacer is a hole partially drilled through with a 1-inch by 1/4 inch neodymium magnet in it. I take that back. That's 1-inch by 1/2 inch. 1-inch by 1/2 inch neodymium magnet in it. Okay, now the way I made this is on the back of this spacer is one of these little guys that looks like this. It's threaded on the inside. It's got 3 holes. It's put dead center on the back of the spacer like that, and then a bolt is threaded into it and put in with Loctite, so that as you rotate the bolt, and you'll see it here, rotate the bolt, the spacer and the magnet turn. Okay, now there's a second one of these. What I did here is I actually drilled a hole the size. See, the hole here goes all the way through the plastic for this piece of PVC pipe. Here, it goes a little way into the plastic just so the PVC pipe sets into it. And then in the center is a hole for the bolt, which is a little bit bigger than the bolt, and then one of these shoved into the hole and secured in place with epoxy and with 3 screws so that the bolt can, from the outside, can come in, thread into this, and that means when it threads into this, it pushes it this way as it pushes the spacer and the magnet out and toward the rotor. Now, why would we do that? Okay. As the rotor with 6 magnets on it goes by the coil, when one of the magnets on the coil or on the rotor is aligned with this coil right here, the magnet directly opposite it on the rotor is aligned with this. And if the magnets on the rotor are all north and all of these are north, then while this is attracting, this is repelling. And as you adjust this in and out, you can get it to the point where that rotor flies by this coil without even noticing it's there. It just barely has any effect on it going by. And when you have all of these adjusted to all of your coils, you have a rotor that you can spin by hand as much as you want to spin it. And that's the secret to getting your generator to work so far over Unity, it's not even funny. You should get 20 times the input power that you put into the machine. You should get that out of it, at least. So that's the secret of the machine. Now, some other things you need to know. This is my 6 and 6 machine. It's got 6 coils in it and 6 magnets on the rotor. So all of these line up at the same time. And the rotors for this machine have a row of magnets that go by here and align with the coils, and then it's got another row of magnets on the rotor out here that align with the opposition magnets that are around the outside of the rotor. So you can do it this way or you can do it this way. This is a bigger rotor, it's a bigger machine, but I wanted the 6 coils on my machine, so that's the way I did it. Now, some other things to take into consideration. Down here you're going to see some rotors that have 12 magnets in them instead of 6. These are 1/4 inch by 1 inch neodymium magnets on that rotor, and there's 12 of them instead of 6. A 12 magnets, or a 1 inch magnet puts out 0.75% of the power that a 2 inch magnet puts out. So if you double the number of magnets, you get 1.5 times the output that you get out of the 2 inch magnets, out of the 6 2-inch magnets. The problem is now you got a lot of money tied up in neodymium magnets. You got to have all the neodymium magnets here. You got to have neodymium magnets in repulsion around the outside edge. Your costs start going up and up and up as you look at different configurations of this system. I think after all the work that I've done, the best thing you could have is some 1 inch neodymium magnets that are about 1/2 inch thick. And so that's why my rotor here is so thick, is because there's 1/2 inch thick neos. There's 2 of them back to back with a little piece of plastic in between. And that's what I've got going on this rotor. It's only got, I believe, I can't remember if there's 6 or 12 on this rotor. I'd have to pull it apart to look, because it doesn't matter if there's 12 magnets on the rotor. There's only 6 can be, only half of them can ever be aligned to the coil at the same time, and therefore half of them can be aligned to the opposition magnets at the same time. So I think what I have is 12 magnets on the rotor and 12 magnets in opposition, and then 12 magnets. I don't know. I'd have to look. I'll have to take it apart. 1, 2, 3, 4. Yeah, I think there's 12 magnets in here in opposition too. But I wouldn't swear to it. Let me look. Yeah, on this machine, some of the magnets are just set into the frame. Like this one is set into, there's one in here, I don't know if you can see it or not. Well, there's one right in there, it's just set into the frame, it's not adjustable. Then here's an adjustable one, and then down here is one just set into the frame. So there are 12 magnets on that rotor, there are 12 magnets in opposition on that one. There's different configurations of this that I've been messing with over the years as I've figured all this stuff out. You're going to build what you can afford to build, and do whatever you're going to do with it. I just wanted you to know how it works, to know what the options are, to know that the smaller, thicker magnets, which are less expensive, actually put out not as much power, but a percentage of the power that the bigger magnets do. I didn't do any testing of these thicker 1 inch magnets. I do know that the 1 inch by 1/4 inch thick Neos put out 75% as far as power goes of what the 2 inch 1/4 inch thick Neos did. So what I did is I doubled the thickness of the magnet, because I know that creates a more dense flux field and therefore should produce more power in the coils. So anyway, that's all the information I got. You got coils that speed up under load. You know how to build a machine that will nullify the cogging from the attraction of the cores to the magnets. You know that you're going to have to switch out your core. That's what this big box of crap is here. That's a whole big box of ferrite, powdered ferrite, for me to pour coils. I got a bunch of work to do on that. I'm in the middle, my garage, if you saw my garage, it's just like, there's a 71, yeah, 71 Toyota Land Cruiser parts all over that bench to rebuild my Land Cruiser. There's my coil winding machine. Here's this machine here on this bench. Here's that machine there on that bench. There's another setup back there that's all electronics for the 3 battery system Tesla switch type operation. There's my poor power supply turned on in. There's my 3D printer. Crap everywhere here. All my tools down this bench right here. All my different tools. I finally got air conditioning in my shop, which is what that is. This is my crazy drill press that I took apart and now operates on a pipe that comes down from the ceiling so that you can put anything as big as you want under here. I got some work to do on my adjustment screws because they're in my way right now. But and then my chop saw, my table saw, and a ton more crap over here. All of this is all electronics and all stuff that I've used to work on this 3 battery system over the years. Light board. I mean, I just got too much time and energy invested in this not to continue to go forward with it, but this is what's going on. So if you got any questions, go ahead and ask.